Okay, hello everyone. In a new video. On this one we are going to solve an exercise related to electricity in the chapters of DC voltage, electric power and energy, and AC voltage. This exercise was a previous one on the brevet exams in 2014 first session, second exercise. The title of this exercise is Study of a Voltage. In order to determine the characteristics of the voltage U delivered by generator G, we connect the terminals of G to an oscilloscope. The adjacent figure represents the waveform of the voltage U. In absence of any voltage, the horizontal luminous line passes through the center of the screen. The settings of the oscilloscope are: the vertical sensitivity is given by 5 volts per division, and the time base Vb is given by 5 milliseconds per divisions. Then the trick in solving such type of exercises is to determine the value of x and y. Here x represents the number of divisions along the x-axis between two consecutive peaks. In this case, it's difficult to count the number of divisions between two consecutive peaks. Therefore, we'll count the value of x from the center, choosing the first point, skipping this. So the number of divisions between these 2 points is given by 1, 2, 3, 4, 5. Then x is equal to 5 divisions. And the value of y is the number of divisions from the center to the maximum point reached by the waveform. So this is the maximum point, and the number of divisions in this case is given by 1, 2, 3. Then y is equal to 3 divisions. Now number 1. Indicate the type of the voltage U. Indicate means that we need to state with a justification. So referring to this figure of the oscilloscope, this axis is labeled by the voltage U, and this axis is labeled by the time t. Then as we can notice that this voltage varies with time, and it's alternately positive and negative, and the shape of this waveform is sinusoidal. Then let's say, since it varies with respect to time, and alternately positive and negative, between brackets, the shape of this form is sinusoidal. Then this voltage, the type of this voltage is AC sinusoidal voltage. Then writing AC voltage alone is not enough, and writing sinusoidal voltage alone is not enough. The type of this voltage is AC sinusoidal voltage. Now in number 2, part A, they are telling me to determine the maximum value UM of U. So the value of UM is the maximum voltage reached by this waveform. So it's the number of divisions, which is 1, 2, 3, multiplied by the scale along the x-axis, which is SV is equal to 5 volts per divisions. Or in another way, the voltage U maximum is given by SV times Y, which is the number of divisions multiplied by the scale along the y-axis. Now, the value of SV is given by 5, and the value of Y that we already determined is given by 3. This will give me 15. Since both SV and Y are in the SI, so the value of UM will be in the SI, which is volts. Then the value of UM is equal to 15 volts. Now, as for part B, they are telling me deduce the effective voltage, U effective of U. Deduce means that we need to use the part just previously before. In part A, we have determined the maximum voltage. Then we can deduce the value of U effective because it's related to the maximum voltage by UM divided by square root of 2. Now, the value of UM is given by 15. Dividing it by radical 2. Plugging this on the calculator will give me 10.61. Since UM is in the SI, which is volts, so U effective will be in the SI, which is volts. Then U effective is equal to 10.61 volts. Now in 3 part A, they are telling me to determine the period T of U. The period is given by VB multiplied by X. Now here the value of VB is given by 5 milliseconds per division. Knowing that milliseconds is not a SI unit of time, in order to convert from milliseconds to seconds, we simply divide by 1000, or milliseconds per division to seconds per division, then 5 divided by 1000. Plugging this on the calculator will give me 0.05 seconds per division. Now the value of VB is given by 0.005 and the value of X is given by 5. Plugging this on the calculator will give me 0.025. Because both VB and X are in the SI, so the value of the period will be in the SI, which is seconds. Then the period is given by 0.025 seconds. Now in part B they are telling me deduce its frequency, and by deduce means that we need to use the part just previously before. In part 3A we have determined the period. We know that the frequency and the period are related via the following formula. Frequency is equal to 1 over the period. Now the period is given by 0.025. Plugging this on the calculator will give me 40. Since the period is in the SI, so the value of F will be in the SI, which is Hertz. Then the frequency of this voltage U delivered by the generator G is given by 40 Hertz. Now in part 4 they are telling me a lamp L carrying the indications 15 volts, 9 watts is connected across the terminals of G. Part A. What does each of the indications carried by L represent? The lamp L carries two indications, 15 volts and 9 watts. Let's start by explaining what is meant by 15 volts. So this is the rated. Since this quantity has the unit of volts and we know volts is the unit of voltage, so it is the rated voltage, of which electric component of the lamp L under which it functions normally. So this is the meaning of the first indication, and the second indication is given by 9 watts. This is the rated. Since this quantity has the unit of watts and watts is the unit of power, so it is the rated power consumed by the lamp L under which it functions normally. Here the maximum voltage is given by 15 volts. Now in part B they are telling me the lamp glows weakly. Justify. In other words, we need to describe the functioning of the lamp. The functioning of the lamp can be described by comparing the rated to the applied. Here we have two voltages and they are given by UM is equal to 15 volts and U effective is equal to 10.61 volts. So in this case we need to compare the effective voltage to the applied voltage because it's the one that makes the effect. Okay, so now comparing the effective voltage to the rated voltage, we can see that U effective, which is said to be in this case the applied voltage, is less than the rated voltage. Then let's say since the applied voltage, which is the rated the effective voltage, the applied voltage is less than the rated voltage of the lamp L, and this is because 10.61 volts is less than 15 volts. We know that in this case the lamp may not function or function weakly, and because they told me the lamp glows weakly, then we will write this answer. Then the lamp L glows weakly. Finally, in part C, they are telling me calculate the electric current that should traverse the lamp in order to glow normally. They mentioned the glow normally, which is functioning normally. Then now we can use the indications. We have the voltage and the power. We need to calculate the electric current, denoted by I. Here, the lamp is not connected to an electric circuit. Then we cannot use the law of addition of currents or law of uniqueness of currents to determine the value of I. And we don't know the resistance of the lamp. However, we can determine the value of the current, knowing that the electric power and the voltage and the current are related via the following formula. P is equal to U multiplied by I. Now constructing the triangle of this formula, here because we have multiplied and P will be at the top, U and I at the bottom, we are interested in calculating the value of I. So putting our hand over I, then I will be given by P divided by U. Now the value of P is given by 9. From here we know that 9 watts is the rated power, whereas the voltage U is given by 15. Plugging this on the calculator will give me 0.6. Since both P and U are in the SI, then the value of I will be in the SI, which is amperes. Then this indication means that the rated current under which the lamp functions normally. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.